Hello students. So in the last class, we had done few problems on uh, similarity of triangles, isn't it? And we didn't do in the proper order. So please check the previous video. We had done last question was question number 3, and now we're gonna do question number 9. So in this figure, ABC and AMP are two right angle triangles, right angle at B and M. We have to prove two things. The first one is we have to prove the triangle ABC is similar to triangle AMP, and we have to prove that the ratio CA by PA is equal to BC by MP. So let's do that. So we have already taken the figure. So ABC is this triangle which I'm going to shade now. So you can see this triangle ABC, and the other one is AMP. Let me shade it in a different way. The two triangles that I've shaded, these are the two triangles that we have to prove it is similar. So the first step is to prove, we have to prove that triangle ABC is similar to triangle AMP. That is the first step. We'll do that. So in triangle ABC and triangle AMP, if you observe, in both the triangles, angle A is common angle, isn't it? Angle A is equal to angle A. The reason being common angle. Okay. Now, if you observe properly in the triangle ABC, angle B is 90 degree, and in triangle AMP, angle M is 90 degree. So let's take angle B is equal to angle M. Both are 90 degrees. Therefore, triangle ABC is similar to triangle AMP using AA criteria. Now, the second part that we have to prove is, CA by PA is equal to BC by MP. So if you have watched the previous video, I told you that if you want to prove such ratios are equal, that is CA by PA is equal to BC by MP, we have to take two triangles and prove that the triangles are similar. Which two triangles should we take? For that, observe the numerator. The numerator here has got CA in it, and here it has got BC. So which is the triangle that has got both CA and BC in it? CA and BC. So it is triangle ABC, isn't it? So we have to take triangle ABC. Then the other triangle is, observe the denominator. In the denominator, we have got PA and MP. So which is the triangle that has got PA and MP? If you observe, PA is here and MP is here. So which is the triangle? It is AMP, isn't it? So we have to take this triangle. So let's take this triangle AMP. So that is, we have to take triangle ABC and triangle AMP, and we have to prove that they are similar. But already we have proved it is similar, isn't it? Triangle ABC is similar to triangle AMP. So we have proved above, isn't it? We have proved it. So let's not prove it again. So if two triangles are similar, corresponding sides are in proportion, isn't it? So how do we take the corresponding sides? The first two alphabets, AB and AM. So the ratio AB by AM is equal to the next two alphabets, BC by MP, and the next two alphabets, AC by AP. So what is the reason? If two triangles are similar, then C dot S corresponding sides are in proportion, isn't it? The corresponding sides are in proportion. That is why we have got it. In this, the required thing is CA by PA. So if you got, we have just reversed here. Here we have written it as AC by AP. So we can write it as CA by AP or CA by PA, which is equal to, and we need BC by MP. It is here. Let's take that. The first one is not required. Okay. Hence, proved. So whenever we have to prove two ratios are equal, this is how we prove. We take two triangles Prove that they're similar. If triangles are similar, then the corresponding sides are in proportion. Okay. So let's get into the next problem. Okay, students, let's see the next question, 10th one. CD and GH are respectively the bisectors of angle ACB and angle EGF such that D and H lie on the sides AB and FE of a triangle ABC and triangle EFG. So it is already given that if triangle ABC is similar to triangle FEG, we have to show the three things. That is, the first one, let's concentrate on the first one. CD by GH is equal to AC by FG. So it is already given triangle ABC. It is given that triangle ABC is similar to triangle FEG. Okay, and I've taken the triangle. As you can see, there is a triangle ABC. CD is the bisector, meaning this angle ACD, which I'm tracing it now. ACD, this angle, and DCB, this angle are equal. Similarly, these two angles, FGH and HGE, these two angles are equal because CD and GH are bisectors. Okay, now it is given triangle ABC similar to triangle FEG. So we know that if two triangles are similar, we can say two conditions. That is, the corresponding angles are equal. So angle A will be equal to angle F, angle B will be equal to angle E, and angle C will be equal to angle G. So let me write that. Angle A is equal to angle B, angle A is equal to angle F, angle B is equal to angle E, and angle C is equal to angle G. It is already given. So this is the first part that we have to prove. So as I told in the previous question, if you want to prove such a ratios are equal, we have to take two triangles and prove that the triangles are similar. How do we take the triangles? Observe the numerator. Here in the numerator, we have got CD and we have got AC. Which is the two triangle that has got CD and AC in it? So it is the triangle ACD. Let me shade that. So this is the triangle, isn't it? ACD has got both CD and AC in it. So we have to take that triangle and observe the denominator, GH and FG. So which is the triangle that has got GH and FG in it? It is FHG. So this triangle that I'm shading. Okay. So we have to take these two triangles and prove that the triangles are similar. Okay, let's take those two triangles in triangle ACD and triangle FGH. Let's prove that triangles are similar. If you observe, angle A is equal to angle F because it is given. The two triangles were similar. Using that, we have got it, isn't it? From here, we can say angle A is equal to angle F. That is this angle, angle A and angle F. Or let me take a different color for that. So angle A is this one, angle A and angle F. These two are similar, these two are equal because the triangles were similar and we have got it. That given the triangles are similar, therefore from that we had written angle A is equal to angle F. So I am writing it. Okay. So now one more thing is, you can say this angle G and angle C are equal. Let me also show it in a different color. Angle G, this angle and this angle are equal. It's very easy because this complete angle C and this complete angle G are equal. It is from the given section. Angle C is equal to angle G. Therefore, if the fulls are equal, their halves. For example, if this angle is 100 degree, G is also 100 degrees, isn't it? But C is divided into two halves. So the top part will become 50, the bottom part will also become 50. Similarly, the top part of G will become 50, the bottom part will become 50. Therefore, if the fulls are equal, the halves are equal. Therefore, we can say that this angle HGF and ACD are equal. Okay. So angle ACD is equal to angle HGF. The reason is angle C is equal to angle G. If the fulls are equal, the half of angle C will be equal to half of angle G. What is half of angle C? I'll take it as angle ACD. Half of G, I'll take it as HGF. Okay, this is the reason. Okay, therefore, if two angles are equal, let me put a flower bracket. If two angles are equal, therefore we can tell the triangles are similar. Triangle ACD is similar to triangle, and we have to be very careful. We have to write the corresponding parts. So A is equal to F. So A is in the first position. So F comes in the first position. And we know that angle C is equal to angle G. So G comes here, H comes here. Okay, using AA criteria. If two triangles are similar, corresponding sides are in proportion. Therefore, I can write AC by FG is equal to CD by GH, which is equal to AD by FH. Okay. What is the reason? If two triangles are similar, then corresponding sides are in proportion. Now, out of this, which are the two things that we need? We need only the first two parts, isn't it? Let's take only the first two, which implies AC by FG will be equal to CD by GH. So this is the first part. Similarly, in the second part, we have to prove the bottom triangle, which is unshaded, BCD and HGE as similar. It is very easy again. We can easily prove that they're similar. Let me take a different color. So if you observe the unshaded triangles, BCD and HGE, that's what we have to prove similar. So angle B is equal to angle E, because it is given, isn't it? It is given here. Angle B is equal to angle E. Okay. Similarly, the half of the angle C is equal to angle G. The half of the angle, this HGE and DCB are equal. If two angles are equal, then the triangles are similar. Okay. This is how we prove the second part. The third part is already proven. In the third part, we have to prove this itself, what we have already done. ACD is similar to FGH, but they have given it in a different way. That's it. Only the alphabets have changed. There we have to prove DCA is similar to HGF, which is nothing but ACD similar to FGH. So the third part and this are same. So let's not do it again. Okay. So let's get into the next question, students. Now let's do the 13th question. See why we are doing in this random order, because these questions have same pattern. So let's do that. So 13th question, D is a point on the side BC of a triangle ABC such that angle ADC is equal to angle BAC. Show that CA square is equal to CB into CD. So that's the 13th question. So we have got a triangle ABC. So let's take a triangle first, ABC. So let's draw one triangle ABC. Okay, one second. Let me erase this. So let's take a triangle ABC. Okay, so this is A and this is B and this is C. So they have given that D is a point on the side BC. So let's take a point D here. So this is our D. Then such that angle ADC. So we need ADC. Let's join A and D because we need angle ADC, isn't it? So let's join A and D. Okay. So this angle ADC here, this angle ADC is equal to this angle BAC, this complete angle. Okay. So this is what it is given. And we have to prove that. CA square is equal to CB into CD. Now, to prove this, just observe, let me write the CA square as CA into CA, CB into CD. Now, I'll transpose one of the CA to the other side, and from these two, I'll get CD to the left hand side. So it will become CA by CD, CA by CD, CA by CD is equal to CB by CA. If you observe, if you cross multiply CA into CA, CA square, CB into CD, we will get back the same thing. So to get this, if we prove this stuff, we will get this, isn't it? So how do we prove this? We have already seen that if you want to prove ratios are equal, you have to take two triangles and prove that the triangles are similar. Which are the two triangles? Observe the numerator. Numerator has got CA and CB. So CA and CB is in which triangle? ABC. CD and CA is in triangle CDA. That is, we have to prove the smaller triangle. Let me share that triangle. This smaller triangle ACD and the complete triangle ABC. If we prove these two triangles are similar, then we can get the required condition. So let's prove the triangles are similar. If we prove similar, we'll get the required answer. So let's take, coming to the proof, in triangle ABC and triangle ACD, we have got, if you observe carefully, angle C is common for both the triangle, whether it is the smaller one or the bigger one, common angle. So this angle, let me shade in a different color. Angle C, if you observe this angle, it is common for both the triangles, isn't it? For the bigger triangle and the smaller triangle, angle C is common. So therefore, angle C is equal to angle C. Now, similarly, from the given stuff, in the triangle ABC, angle A, that is a complete angle, BAC, is equal to ADC. This is given. So we have shown that two angles are equal. Therefore, the triangles are similar. Therefore, triangle ABC is similar to triangle. We have to be very careful. Observe, in the bigger triangle, angle A was equal to angle D. So this is the bigger triangle A. Okay, ABC. The A here is the A of the bigger triangle. So that A was equal to D. So we have to write D here. And C is equal to C. So C comes at the last. So we have written D and C, which is the left out alphabet A. So triangle ABC is similar to triangle DAC using AA criteria. Now, if two triangles are similar, corresponding sides are in proportion. Therefore, we get AB by DA is equal to BC by AC, which is equal to AC by DC. Now, we'll take the last two things to get the required thing. So, if you cross multiply BC into DC, which is equal to AC into AC. AC into AC is AC square, or I can also write it as CA square. That will equal to BC can be written as CB, DC can be written as C. Therefore, let's write it in reverse order. CA square is equal to CB into CD. That's how we have proved it. Okay. So let's get into the next question, students. Okay, students, let's do the fourth one. Now, whatever questions we have done in the previous video and this video are completely based on AA criteria. Now, from now onwards, we'll be using SAS criteria and SSS criteria to prove the triangles are similar. Okay. The fourth question is one such question where we will use SAS criteria. Now, in the fourth question, it is given that QR by QS is equal to QT by PR, and angle 1 is equal to angle 2. We have to show that triangle PQS is similar to triangle TQR. So I have taken the figure. So given things are, what are the things that they have given? They have given us QR by QS. QR by QS is equal to QT by PR, isn't it? So QR by QS is equal to QT by PR, and angle 1 is equal to angle 2. Okay. What we have to prove is, we have to prove that triangle PQS is similar to triangle TQR. Now, if you remember, I told you that if you want to prove triangles are similar, it is very clear. We have to prove these two triangles. Triangle PQS is similar to triangle TQR, isn't it? So very clearly, angle P will be equal to angle T, angle Q will be equal to angle Q, and angle S will be equal to angle R. We have to just find the reasons why they are equal. Okay. Now, if you observe, the triangles that we have to prove similar is, let me shade it. So triangle PQS, that is this triangle PQS. Let me shade it. The one which I've shaded in red color, PQS. So this triangle, and the other triangle is TQR, that is the complete triangle, the big triangle. Okay. So let me draw the outline for that. TQR, this complete triangle. Okay. So we have to prove that complete triangle is similar to the smaller triangle that I have shaded. Okay. Now, as I told you, angle P is equal to angle T. So let me take a different color. Angle P is this one. Okay. Angle T is this one. Now, why are they equal? We don't know, isn't it? Is there any particular reason? So we don't. Okay, let's observe the second one. Angle Q is equal to angle Q. Now, this angle Q is equal because if you observe, the shaded triangle and the big triangle both contain this angle. That is, Q is common for both. Okay, we got to know why Q is equal to Q. Now, let's find why S is equal to R. S is this angle, S is this angle, and R is this complete angle. Okay. Why are these two equal? Again, we don't know why are they equal. Okay, you can try it out. We don't know the reason why they are equal, isn't it? So here, we know that is only one angle is equal. To prove triangles are similar, we at least need two angles to be equal. But here we know only one angle is equal, which means we have to use some other criteria other than AA criteria. So let's come to the proof. So in the proof, so let's take triangle PQS and triangle TQR. We know one angle is equal. Angle Q is equal to angle Q. That is common angle. Now, if you observe, they have given us something, right? Let's use that. QR by QS is equal to QT by PR. It is given. Now, what is SAS criteria? SAS criteria tells us that one angle should be equal. It is here. And sides containing the angle. So, in triangle PQS, the angle Q is between what? QP and QS. Isn't it? So, QP and QS. For the bigger triangle, the angle Q is between QT and QR. Isn't it? QT and QR. These four sides have to be in equal ratio. That is, if you take the ratios, QP by QT, QS by QR, it should be equal. If you observe, they have taken the ratio of QT and QR. QT and, okay, just observe, here we have got QP, QS, QT, QR. Now observe here we have got QT, QR, QS, isn't it? The only thing that is not there is QP. If QP was here instead of PR, if QP was here, then using SAS criteria, we could have concluded that the triangles are similar. Now, all we have to do is we have to prove PR is equal to QP. That can be easily done because they have given angle 1 is equal to angle 2. If angle 1 is equal to angle 2, observe angle 1 is this Angle 1 is this and angle 2 is this. So if two angles are equal, then the triangle becomes similar. So which is that triangle? PQR implies triangle PQR is isosceles. If two angles are equal, then two sides are equal, which implies QP is equal to PR. Therefore, I can take out that PR, which implies QR by QS is equal to QT by, I can take out that PR and I can write it as QP. Now, let's take this as equation 1 and let's take this as equation 2. Now, from 1 and 2, the triangles are similar. Triangle PQS is similar to triangle PQR using SAS criteria. Now let me repeat it again. What is SAS criteria? One angle should be equal. One angle should be equal. Let me erase all the stuff. So one angle should be equal. If you observe this angle Q is equal to both the triangles. Okay, one angle is equal. What are the sides containing the angle? In triangle PQS, QPs and QS are the sides containing the angle. So QP and QS. Similarly, in other triangle, the big triangle, QT and QR are the sides containing the angle. So these four sides have to be in proportion. That is, if you take the ratios of these sides, okay, these four sides should be equal. The ratio should be equal. Now, if you observe that given as a ratio, isn't it? In that ratio, we have QR, QS, QT. Okay, that is, this is there, QS, QR, QT is there, but this QP is not there. If in the question, instead of this PR, if they had given us QP, these four sides are in proportion, therefore we could have told that the triangles are similar. So, but PR is given. So how do we write it as QP? They've also given us another end, that is angle 1 is equal to angle 2, that is this angle and this angle. So therefore the triangle PQS, let me trace this out, PQR, sorry, this triangle. Okay, let me erase everything and draw it. So triangle PQS, sorry again. So this triangle. So in that triangle, angle 1 and angle 2 are equal. If two angles are equal, then it's an isosceles triangle. Therefore, the opposite sides, angle 1 opposite side is PR, angle 2 opposite side is QP. Therefore, QP will become equal to PR. So take out the PR in the given thing and replace it by QP. So one angle is equal and the sides containing the angle are in proportion. Therefore, the two triangles are similar using SAS criteria. Let's get into the next question. Let's take the sixth question now. In triangle or in the figure, triangle ABE is congruent to ACD. We have to show that triangle ADE is similar to triangle ABC. Okay, let's do that. So I've taken the figure. So what is given? It is given that triangle ABE is congruent to triangle ACD. Now, same stuff. If two triangles are congruent, then the angles are also equal, isn't it? Congruent means shapes and size both are equal. Therefore, we can tell angle A is equal to angle A, angle B is equal to angle C, angle E is equal to angle D. Along with this, we can also say that the corresponding sides are equal. If it is similar, corresponding sides are in proportion. That is, the ratios will be equal. But here the triangles are congruent. Therefore, we can tell corresponding sides are equal. Instead of proportion, we can tell that the corresponding sides are equal. So I can tell AB equals AC, BE is equal to CD, and AE is equal to AD. Okay. If two triangles are congruent, we can tell the angles are equal and sides are equal. But if two triangles are similar, angles are equal, but the sides are not equal. The sides are in proportion. Okay. Now, what should we prove? We have to prove that Here we have to prove that triangle ADE is similar to triangle ABC. That is, let me shade it. The triangle AD is this triangle, the smaller triangle, and the complete triangle. Okay, the smaller triangle and the big triangle ABC, we have to prove that the triangles are similar. Okay, let's do that. So if you observe, both the smaller triangle and the bigger triangle, that is ADE and ABC, angle A is equal, isn't it? So angle A is equal to angle A, common angle, or you can also write given. Okay. The next step is, see, we got to know why A is equal to A, but why D is equal to B and E is equal to C is not known. So let's, meaning we cannot do it by A criteria. Then we have to use SAS or SSS criteria. So since we know one angle is already equal, let's go with SAS criteria. If you observe from the given data, I can tell AB is equal to AC and they have given AE is equal to AD, isn't it? From the given data, I can tell AE is equal to AD. This is given. Or they've also given that AB is equal to AC, isn't it? We have written it, given. It is here. Two triangles are congruent. Using the given rule, we wrote this, right? Out of this, let me take the first one and the last one. Okay. Now, let me take this as, equation 1 and equation 2. Why are these two equal? Because it is given. Now I'll divide 1 and 2. If two things are equal, even after dividing, they'll be equal, isn't it? So AE by AB will be equal to AD by AC. Okay. If two things are equal, even after dividing, they'll be equal. Now, if you observe, let me take a different color for this. This angle A is common. In triangle ADE, which are the sides containing the angle? AD and AE. These are the sides containing the angle. In triangle ABC, it is AB and AC. That is, the sides containing the angle are AD and AE. In the other triangle, the sides containing the angle are AB and AC. So these sides should be in proportion. If you observe here, that is what we have got. We need AD, AE. We have got it in the numerator. And we need AB and AC. We have got it in the denominator. So these four sides have to be in proportion. That is, if I take the ratios must be equal. So it is equal. Therefore, it is following the SAS criteria. Therefore, triangle ADE is similar to triangle ABC using SAS criteria. Okay. So we'll continue with the next problems in the next video. Thank you, students.